Hey guys, today I'm gonna show you how to operate the TM4000 Plus scanning electron microscope. I've been trying to do this for a long time now, but haven't got the courage to. Today I finally got the chance, so let's do it. For this particular model, the switch is here, so it flipped it, and it will evacuate the chamber. Now, I think it's probably fine to just hit that button and introduce air right now, but like I don't want to risk it. I have time to spare, so I'll let it evacuate completely and then introduce air to it so that I can load my sample. Speaking of sample, today we are looking at mineral grains. So SEM can actually be used to look at everything, a lot of things, but now today we're doing mineral grains. I don't know if you can see it. You see the black stuff? Yeah. So what I did is I mounted the grains in epoxy resin so that we can use it to observe. There are some dents, which is ugly, but it's gonna be fine. Anyway, let's wait for it to evacuate and I'll show you the rest. Now it's completely evacuated. You can see from the light before it's blinking, now it's just blue. Hit that button. It will start to introduce air into the chamber. Once it's done, we can pull this open and load our samples. And we're gonna wait for like 30 seconds to 1 minute. In the meantime, we can, oh, it says ready for observation because it's done evacuated. Anyway, we can start that. Okay, so I usually use 15 kilovolts. It's so, come on. The mold doesn't really matter. Try everything. It's only giving us a few choices here. So like 15 kV mode 2, 15 kV mode 3. There's no 15 kV mode 1 and 15 kV mode 4 here. It's actually over here. So menu and where is it? Scan setting, I believe. Nope. Oh, accelerating voltage setting. Now you can choose every kilovolts and mode everything. I don't really, okay, it says mode 1 is resolution, more resolution, but mode 4 is like more contrast. I'll choose 15 kV mode 4. It's very intuitive. Just, yeah, so your camera probably wouldn't be centered right on the sample you want to see. So you can just tap here, or you can double click, right? Double click there, or double click here. It'll move. Move to your desired location. I don't think that is, but we can autofocus. It'll do it automatically, which is very, very good. And let's find the thing I'm looking for. Here it is. Yep. There you go. You can do auto brightness and auto contrast. I advise zooming in before you do that. For example, I want to look at this grain. Do autofocus again. Do auto contrast again. And there you go. That's a pretty small grain. It's only 100 micron. Well, it's pretty big, like compared to the rest. You can choose fast scan or slow scan here. Fast scan will like be faster, but the resolution will be pretty low. Slow is very slow, but resolution would be pretty good. See? Yeah, that's beautiful. That is beautiful. Remember I said I'm gonna be looking for two distinct mineral phases. How do I know that? One method is to look at the brightness. If the brightness is different, chances are, see, that one is totally different. Chances are there are two different mineral phases. But another thing you can do is using EDS paired with the SEM, which is, ooh, what is this? Yeah. EDS, okay, which is energy dispersive spectroscopy, X-ray spectroscopy. There's a bunch of names. This is what I'm gonna be using, Brucker thing up. Okay, there you go. What I recommend is to start the SEM first, and then you can open the EDS. It's gone. If the microscope voltage here is not the same as this one here, it's not gonna work. So if you start this first and then start that, this one here will say 0, or like it's not gonna pair up. So let's zoom in on that and actually do this. What EDS does is basically tells you what thing it is. It tells you the elements, but close enough. Zoom in, autofocus, auto brightness and contrast. Come to the EDS menu, software thing. I am going to be using this one. You do capture. You can do preview first, but we can preview from here already, so there's no need for that. I'm going to just use capture, and it will capture the image right here. What you're gonna do is here, you can select a bunch of things, a single point, an area, another area, or a bunch of points. What I usually use is just a single point. What you do is click that, click on the thing you want to analyze. There you go. And then select all, make sure they're all selected, and then do acquire. You can change some acquire settings here. For example, I don't really need it to run for 30 seconds. I don't need it to be that accurate. I could just do 15. And that's totally fine for my purpose. You can see it's doing its job. It's scanning. I think it's blasting electrons. And then based on the reflected stuff, it'll tell you what it is. I already know what this sample is. Oh, by the way, right click, auto scale, you can do that. I already know what this sample is because this is experimental sample, this is not natural sample. There is basically TiO2 and some Ta2O5, which is rutile and tantalum oxide. I put in there. So from my past experience, I know that this darker phase is rutile and that brighter thing should be tantalum oxide. In here, can again do select all, so it selects all of the stuff. Over here, you can see this little periodic table looking thing. Click that. That is the auto identifier. If you're using a natural sample, you can just auto ID, but sometimes it's not that accurate. It'll pop up some like irrelevant elements. PT is relevant because I used the platinum capsule to do the experiment, which is damn. Okay, so that's platinum. That's not tantalum oxide. Whatever. If you're doing if you're using an experimental sample, you should know like what element you put in there. So you can just click them to add them to the spectrum, TI, TA, and as you click, it's gonna show up on this page, and they're done. What I like to do is, if you want to see it one by one, select all first, or you don't have to select all. You can just click this, deselect all, and do it one by one. Auto scale. I want to like make the text not obstructing my peaks. I think it's here in the lines. No. Oh wait, yeah, lines. There we go. Okay. I can see, for example, spectrum 1 is what I'm selecting. It's over here, it's this grain. I can see it's TI, and there's O over here, which I deselected. So basically it means that's TiO2. Tantalum is pretty compatible in rutile. It'll basically substitute one of the titanium atom. It will get into the rutile crystal structure. Rutile crystal, like rutile formula is TiO2, right? And yeah, that's that grain. If you want to see another one, this one. By the way, if you want to see 2 grains at once, press Control. Oh, it's gonna be hard. I'm just gonna do this and show you. Press Control and use your mouse to click. So here, you can see I selected these 2, which is the brighter phase over here. It shows the platinum very high, so I know there's platinum metal in it, and there's TI and TA signal as well. It could be resulting from alloying, or it could be the EDS picking up signal from the surrounding. Could be both. Oh, by the way, if you want to save the thing, this button lets you add to report. I've never used add to project, but add to report basically generates a PDF for you. It says blah 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 blah, yeah, doesn't matter. There you go. That's it. It's in here if you want to look at it. Report. And you see, we selected all, so everything here is highlighted. If you just want to highlight a few, select a few. For example, I only selected spectrum 1. And there, add to report. And there you go. Only spectrum 1 is highlighted. These colors, so now the line, the thing is filled. If you click that, it'll become lines. That, yeah, the mouse thing lets you zoom in, zoom out. Drag this. You can also drag this to zoom in and zoom out. It's just little tricks. Ask around your lab people should know more than I do. Yeah, if you want to add this graph, go over here. This is the periodic table thing. Here, this, export data or image. Add to project. Oh wait, add to report, yeah. And there you go. There's our thing, the graph. And that's it. That's basically what I usually use EDS for. People also use EDS for detecting concentrations, which is, I'm not going to use that today. It's a very hideous process. Well, not that hideous, but takes time. Capture. It says save everything because it'll be wiped. I saved. Do that. These points will still be here. So select all, and delete. It'll clear the thing. And select the thing again, the point. And just click, click, click. It's just all clicking. Acquire, select all, acquire. Even if it's not done, you can still come here and auto ID it. And that is nickel, because I'm also using a nickel capsule. There you go, nickel. So that thing. So except for this setting, I'm using BSE. BSE, basically it means it tells you the thing, what the thing is, it shows contrast and stuff. Another thing you can do is SE, which stands for secondary electron. BSE is backscattered electron. SE lets you to see the topography, which is like strictly the topography. Again, auto focus, auto contrast brightness, turn it to slow, and we'll see the topography of this thing. Our SEM is a bit old, and I think some of the hardware stuff has really aged a bit, so you can see the flare kind of thing. But it doesn't really affect me because I don't really do topography work. But just to show you what it looks like. For example, let's come here. Again, autofocus, auto brightness. Turn it to slow. If you want, you can manually adjust the brightness, manually adjust the contrast. That's really dark. And there we go, that's my ugly, full of crevices grain. These might be resulted from polishing, or they might be inclusions, fluid inclusions, I guess. Anyhow, I don't know about other SEM, but for this model specifically, there's a mix one. I've used it before, I don't like it, but it really depends on what task you want to do. You want to do topography thing, use secondary electron. You want to like distinguish between different stuff, use backscattered electron. Gonna make another video talking about the difference, like the mechanism ish behind these two guys. But for now, I'm gonna switch it back. If you want to take a picture, I'm sure lots of you noticed that by now. Quick save and save. Quick save is just, it saves this fast image. Save is saving the slow image. If you want high quality images, do save. Okay. Rename it here. Select where you want it to save. This thing, use magnification. Camera, please. Use magnification. It basically adds the current magnification to the end of the file name. So like times 800, it'll save as like parentheses and then times 800. I usually do that. File type, you can save. JPEG, I think it'll kind of compress the image a little, but TIFF will give you, wow, what is that wedge thing? Will give you a high quality stuff, metadata. That will, I think this will give you a text, also generate a text document, which stores all the like electron volts, the magnification, the vacuum status, detector, mode something, everything. You could execute the image optimization stuff. What it essentially does is, I think, it will auto contrast and auto brightness again. Well, it'll tweak the color of the image. If you want the image to stay the way it is, don't do that. Save it to a, ooh, look at that. That forums. Yeah, I'm looking at minerals. Somebody is looking at paleontology stuff. Others maybe, I don't know, look at brains. Let's save it to desktop for our purposes and save. It should be saved by now. Every time you save an image, the SEM status will turn into freeze. If you want to move again, do fast or slow. I've never used reduce. What is that? Oh. Okay, not gonna use it. Anyway, here, there's our files. You see, this is the result of including the magnification thing. It'll give you the magnification here. Open it, and it is really high quality image. Well, if you zoom in, it's not that high quality, but it's pretty impressive. That's like 50 micron. Jeez. This is the document I'm talking about. Come on. Instrument name, version, blah, 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 just anything. I usually generate this. Sometimes it'll help backtracking stuff. Anyhow, there you have it. That's how you operate the SEM. And now I'm gonna talk about how you clean up. I'm here again, press, it'll do like introduce air. And now it'll show this. Because air is introduced, the SEM will be stopped. It is best that you press stop here first, but if you forget about it, I don't think it's that much big a deal. It'll stop automatically. Okay, it's done. Take this out. Careful with that. Get your sample off and put it back. Focus on iPhone is really trash. Okay, so because there's no like lock thing on this model, I don't know about other SEMs, what we do is we evacuate it so like the atmospheric pressure will keep it locked. No dust will get inside. And that's basically it. You wait for it to completely evacuate and you flip the switch and it's done. And you can close this as well. The application exit manager. Yeah, we're just gonna wait here. I'm just gonna stop the video here. Wait for it to be steady blue and then flip the switch. That's how you do it. Thanks guys, I think that's all, and have a good day.